So I want to take a minute to explain why carbonaceous chondrites are incredibly important. And as we now know, not only carbonaceous chondrites, but comets are incredibly important to the early evolution of life on our planet. So as you've learned, hopefully both through the reading and through my PowerPoint slides, that meteorites called carbonaceous chondrites are carbonaceous because they can contain up to 5% amino acids. Now, why would that be important, right? First of all, we need to figure out, what do amino acids do, right? What do they do? If you've ever taken biology, right, basic biology, hopefully you remember that amino acids can make the proteins, they code for the proteins that make DNA. So obviously amino acids are incredibly important. They are the cookbook for making us what we are today. So how can these carbonaceous chondrites, or comets and comets as we now know, how could they have supplied Earth with the first building blocks? Well, let's say, here we are. I'm going to draw you a scene here. Here we've got an underwater scene, right? Lots of water. No life in the water, though. Just lots of water. Maybe you've heard this term primordial soup before. This is what we're getting to. So let's say here we've got a carbonaceous chondrite, and it's falling into the ocean. Or we have a comet. Because comets, interestingly enough, also contain amino acids, and they fall into the ocean. So what will happen is now you've got this rock, right, sitting in the ocean, hanging out, and it's got those amino acids. Those amino acids are going to start leaching out into the water. So those amino acids, let's pretend those are just these black dots, they're going to start floating around in the water. That's what that primordial soup is referring to. Now, amino acids themselves won't do anything in the water. They're just going to hang out. They're really not going to go anywhere. They're just going to sit in that water and have a nice time hanging out. However, if we can somehow electrically stimulate this water, and the best way, let's think here, the best way to electrically stimulate this water without humans, because obviously this occurred long before humans around, would be through lightning, right? So here, let's say we have lightning, right? Lightning crashes into the ocean, and now we supply the ocean with electricity, right? Some sort of electrical charge. What happens with that is these amino acids start coming together and start coding for DNA. So when you take these amino acids, supply them with an electrical charge, of course they have to be in water, they start making very basic DNA sequences. Now this should be awesome to you, right? Hopefully your mind is going, holy cow, this is amazing. So this is what we mean by primordial soup. With all these carbonaceous chondrites and comets hitting the ocean, we have all of this stuff in here, all the blueprints to essentially start coding for very basic DNA. So as this starts, then we start getting our nice single-celled life, our amoebas and our other sorts of prokaryotes, right, floating around in the ocean. And of course, they're going to continue to evolve. So what this means is that the building blocks for our planet, for life, were brought here from outer space. That's pretty amazing. And what's also pretty awesome is we have proven this. This has been proven. We have done these experiments in the lab to see how these amino acids could make DNA. So we know this is how it works. And we know both those carbonaceous chondrites and those comets all have those amino acids. So without a doubt, this is how DNA was brought to our planet. This is a pretty amazing thing, and that's what makes those carbonaceous chondrites incredibly important.